All right, let's see if we can improve our model a little bit by using filter-based feature selection. Now, this is a tool that allows us to select attributes that are best, and let's see how it works. I'm going to make a little bit of space down here for my filter-based feature selection. And if I go back into my components and type in filter, you'll see I've got my filter-based feature selection. So if I run it, I'm just going to attach it without doing anything to it right now. If I run it, first thing it says is operate on feature columns only. That's true. We could change it so it runs on all columns, but we just want to run this on the features. We'll supply the target column name, which is charges. And then it says, how many features do you want to keep? So this is a good one to use when you have many features. Of course, we only have 1, 2, 3, 4, 5, 6 features. So let's say we want to keep the top 4. All right. And then we can use either a Pearson correlation or a chi-squared. Now, Pearson correlation is useful when all of your features are numeric. Chi-squared is better when you have categorical features or a mix. So I'm going to go with chi-squared. And let's go ahead and run it and see what we get after we update the node first. Now, because I've just run the rest of this before, hopefully it will be a fairly quick run. All right, let's take a look at our outputs. And we can take a look at the filtered data set. And we can take a look at the features. So if we look at the filtered data set, it outputs just those features, those top 4 features that it chose, which are age, smoker, BMI, and children, to go with charges. And then it gives us a ranking of each of the features. So we could see that age was our number 1, smoker number 2, BMI number 3, children number 4, then region and sex being number 5 and 6 were dropped off. So we've got basically a feature relevance score here with charges. This is using just a pure correlation approach. So it's not doing anything fancy, and this works the exact same way no matter which algorithm you are choosing for your model. So now I've got my filtered data set. That's going to be only the 4 best features. Okay, now that we have figured out what our best features are, our top 4 features at least, we can actually apply this filter-based feature selection automatically to our model training and scoring, and then we would be able to apply this automatically in production as well. First, let's go and fix our select columns here. All right, so I've got my filter-based feature selection. And I'm going to try and make a little space here. So instead of connecting my split data training data set to the train model, I'm going to filter those top 4 features out and just send those 4 features into my train model. From there, I can now do a select columns transform. So let's take a look at that one real fast. So if I do a select columns transform, I take my data set from my filter-based feature selection and apply it and connect it to select columns transform. The next thing I'm going to do is add and apply transformation. Right here. So the column selected is basically the transformation rules that I have. And this could be any transformation. It could be a calculation, or it could be some other type of function that I want. So now I've got my filter-based feature selection. I've chosen the 4 columns I want to include, plus my label. I'm coding that up as a transformation, which is basically like a model, a set of rules that machine learning can use. Then I'm going to apply that transformation to my holdout data before I feed it into my score model. All right, so let's take a look at this one. Change the name. Top 4 columns transform. And we'll give this a name. Apply FBFS transformation. Ooh, I don't think I can use caps. All right, so we've added just a couple more steps in here, and this allows us to automate the way our model goes. We're going to select our top 4 features, train our model, and then we're going to split those 4 features off and select just those 4 features for our split data. So this is kind of the equivalent of saying select columns in data set, but only select the top 4 after you know which the top 4 are. All right, so now we'll run this one more time and see how our model does. And we can go take a look at our job that's running. And we have our scored model. So we can preview the data, our scored data set. Now just has our top 4 features, the actual charges, and our scored or predicted charges. Let's see how our model performs. Now we took away 2 of our features, but we still have an R squared of 0.74. Now I can't remember exactly what the number was before, whether this is a tiny bit higher or a tiny bit lower. I would suspect it's a tiny bit lower, but still that's pretty high. So by just choosing our best features, we were able to get the performance, pretty much equivalent performance, and simplify our model somewhat. So that's another consideration. Simple models are generally preferred to more complex models, all other things being equal. All right, let's get back to our reading module and see what we'd like to do next.